Hello everyone. Today I'll be explaining you or I'll be showing you the example walkthrough of Leetcode question number 3721. So suppose we are given an array 2325, right? And now we will be finding the length of the longest subarray, that is balanced. So how we will be doing it? So as we have discussed in the approach, we have simulated uh, all the things using a different array A, and then we are making a segment tree of that A. So what will be this segment tree initially look like? So see, this first node will be handling the range from 0 to 3, and initially A has all zeros, so it also has all zeros. Then its two child, one is from 0 to 1, other is from range 2 to 3. Then 0 to 1 again has two childs, from 0 to 0 and from 1 to 1, and 2 comma 3 wala again has two childs from 2 comma 2 and 3 comma 3. And as we have discussed that each node has one minimum value, one maximum value, and one lazy value. So initially for all these nodes, those values will be 0 only. So see, and we have discussed when we expand our what we call right index. So initially suppose our right index was -1, so now we will be expanding it to 0. So our new element to add is 2. Okay, and 2 is an even number. So what is the value that we will be adding? We will be adding -1, right? Now what we do is we will be checking which ranges are affected due to the adding of this element 2. Okay, so if you'll see, there are no previous elements than 2. So it wasn't previously present in this segment tree. 2 wasn't previously present in the segment tree, right? So what are the ranges that it will be affecting? So it will be affecting all the ranges from 0 to r. And now r, the value of r is 0, so it will be affecting the range 0 to 0. So what we do is we will be update the affected range in the segment tree, right? So let's see how we will be doing that. So see, I have already made this segment tree, right? This is our initial segment tree that we have above seen. Now our affected range is from 0 to 0. So initially we will be calling a function 0 to 0, and -1 is the value. So see, we will be checking this range with this range. So what are the three cases? That there is no overlapping between the ranges, no overlapping is there. Or second case is full overlap, so here full overlap is not there. Third case is partial overlap. So here partial overlap is there. So in case of partial overlap, what this node will do is it will first push its lazy value to its children's. So here its lazy value is 0 only. So either pushing is won't be any effect. Suppose this lazy value has 1, then it will be pushing that value 1 to its children, all the childrens, and then their minimum maximum, and their lazy value gets updated due to this. But here the value is 0, so nothing will be updated in both the childrens. Now what this node will do is after pushing it will call its left child, this left child. So we are present at this node. So this node is handling from 0 to 1. So again see, uh, it is again partial overlap. So again this node will push its lazy value to its children and call its left child. So it call its left child 0 comma 0. So see, this is full overlap. So in case of full overlap, what we'll do is we'll update, we'll directly call the function apply. So apply will add this value to the minimum, maximum, and lazy. So our now our minimum, maximum, lazy value become -1 and -1, right? So now this node has get updated, and then after we get full overlap we'll return back. So we'll go to this node, right? Now what this node will do is this node will call its right child. See, so here right child is 1 comma 1. and our current range is 0 comma 0, so there is no overlapping, so nothing will happen, it will also return back, right? Now at this node, what it does is it has updated its left child, it has updated its right child. Now what it does is it will update its minimum and maximum as its child has get updated. So it will fetch the minimum from this. So here, from here it will get minimum as -1, here it will get minimum as 0. So minimum of -1 and 0 is -1, so its minimum will get updated to -1. Similarly, here maximum is -1, here maximum is 0, so maximum will remain 0 only. So it has updated its minimum and maximum, so it will also return back. Now we came to the initial what you call this, right? Then it will call its right child, so it's 2 comma 3. 2 comma 3 means no overlapping with 0 comma 0, so it will return back, it does nothing. Now again it will also update its minimum and maximum, so it will take minimum from here as -1 and from here as 0, so overall minimum is -1, maximum here 0, here also 0, so maximum of 0 comma 0 is 0. So for this node so for r is equal to 0, we have updated the tree, right? Now what we have to do is we have to find a index L in range 0 comma 0 to R, where this a of L is equal to 0. So what is our range? 0 comma 0, right? So first we will, now we are finding the index L, so we will see this. So 0 comma 3, so overlapping is there. So if you'll see minimum, its minimum and its maximum, so its minimum is -1 and maximum is 0, so there is a chance that 0 can be formed here, right? So in case of checking this, we've used three cases. One is if no overlap, then we return -1. Second case is either minimum is greater than 0 or maximum is less than 0, means it is not possible in that range to get the sum as 0. In that case also will return -1. What is the third case? Third case is like the node is a leaf node, means left part of the range and right part of the range is equal. In that case we will be returning our index L. And if these three cases are not there, then what we do is we will wait. In that case what we will do is we will first push the lazy value to the children's and then check the left children, and if we don't get any answer from the left children, then we get check the right children, like the case of partial overlapping. So if you'll see here, it is 0 comma 3 and our current range to check is 0 comma 0, so partial overlapping is there, right? So what it does is, so there is no lazy value, so first it will push the lazy value, but lazy value is 0, so none of these will be getting updated, right? So first, then it's called its left children 0 comma 1. Again 0 comma 0 has partial overlapping with 0 comma 1, so it will also call its left children. So see 0 comma 0 and 0 comma 0, but overlapping is there. But if you'll see the second condition, minimum is greater than 0, no, minimum is not greater than 0, or maximum is less than 0, yeah. So here the value of max is -1, which is less than 0. So in this range 0 comma 0, it is not possible to form a what we called sum as 0, so it will be returning -1 to this. Then we went to 1 comma 1, so 1 comma 1 and 0 comma 0, no overlapping is there, so it will also return -1. So here in this left node return -1, right node also return -1, so this will also, this node will also return -1 to its parent. So at 0 comma 3 we get -1 from the left child, so we'll be checking the right child. So here right child is range is 2 comma 3, but our range to check is 0 comma 0, so no overlapping, then it will also return -1. So 0 comma 3 we'll return -1 for, so we get our answer -1 means, what does -1 means? There is no index L possible in range 0 comma 0 where a of L is equal to 0, right? I hope this first part is clear to you. Now what is the next? So now next what we'll do is we'll shift r to 1. Okay. Uh, okay, so now our r is equal to, our r is equal to 1, that is the new element will that we have to add is 3. So as 3 is odd, so what will be our value? Our value will be 1. So if you'll see what will be our array, 2 3 2 5, right? So if you'll see there is no 3 present before this current r. So what will be the range that it will be affecting? So it will be affecting all the ranges from 0 to 1. Yeah, right. So our, we get our range that will be affected 0 to 1. So what we do is we will now update all the ranges that are affected. So see, first we come to 0 comma 3. So 0 comma 3, is it no overlapping case? No. Fully overlapping? No. So it is a partial overlapping case. So in case of partial overlapping, first push the lazy. So lazy value is 0. So it won't be pushing. Next we went to 0 comma 1, means it calls its left child. So 0 comma 1 and 0 comma 1 means fully overlap. Okay. So in case of fully overlap, what we do is we directly call the apply function. And in what apply function it does is it will just add the values in minimum, maximum and lazy. So our current value is 1, so minimum -1 plus 1 it becomes 0, maximum 0 plus 1 it becomes 1, lazy become 1, and we return, right? This is the only thing that we do. Now we have updated the range. Now what we do is we will find a index L in range 0 to 1, such that that gives us the what we called a of L is equal to 0, right? So first of all, our range is 0 to 1, so we come here. So we see, is it a case of no overlapping? No, overlapping is there between 0 to 3 and 0 to 1. If you'll see the minimum and maximum, so minimum is less than uh, 0, maximum is equal to 0, means there is a chance we can get 0. थर्ड केस, क्या L is equal to R है? No, L is not equal to R. So this will also not give us our answer. So this is the fourth case, that is partial overlapping case. So in partial overlapping case, first we push the lazy value, so there is no lazy value. Then we call the left child. Okay, now we call 0 comma 1. So again we check the first three condition. Is there any overlapping? Is there any case of no overlapping? No, overlapping is there. We check the minimum and maximum. Is minimum greater than 0? No, minimum is not greater than 0. Is maximum less than 0? No, it's 1, not less than 0. Is L equal to R? No, not case. So again, it will call its left child. Now you see, this node has lazy value as 1. So what it does is it will push the lazy value to its children. So it will push 1 here. So -1 plus 1 is 0. Again -1 plus 1 is 0, lazy 0. It will also push the same value to its right child. So right child has become, minimum is 1, maximum is 1 and lazy is 1, right? So it first has pushed the lazy value, and now the lazy value in this node has become 0. Now we went to 0 comma 0. So see, uh, then again we check the three cases. So here L is equal to R, right? So if you see, is there any chance we that minimum is equal to 0, maximum is equal to 0 and L is equal to R, then we return our L length index, that is, what is the L? 0. So this will return as the index 0. As if you'll see currently our A array will look like 0, 1, 0, 0. So see, A of L is equal to 0 at 0. So we get our answer as 0 from here. Then we went to the right child 1 comma 1. So in 1 comma 1, is there any overlapping? Yes, overlapping is there. Overlapping is there. Then we check the second case, that is minimum and maximum. So if you'll see, minimum is greater than 0. So it is not possible to get 0 from here. So from here we will be returning minus 1. But already we have get our answer 0 from here. So we will be returning this answer 0. And at the end, for this range 0 comma 1, we get the index as 0, right? So what will be our, then we will be moving our, again shifting our right pointer to 2. At r is equal to 2, our element is 2. So if you'll see in the array, so now we are at here. So if you see, already we have 2 at index number 0, right? At index number 0 we have already 2. So this element would not affect those ranges, like this element, this new element would not affect those ranges that had index 0, because adding 2 to a range that already has 2 won't be making this 2 as a distinct number, because right now we are saying distinct even or distinct odd. So if the range has already 2, adding of this 2 won't be make any change to that range, right? So and also 2 is even, so what will be the value? The value will be minus 1. So if you'll see the range affected, ranges affected are from this index I plus 1 to r. So I 0 0 plus 1 to the current r, that is the range affected is 1 to 2, right? Now what we'll do is we'll update the segment tree with the current range, with the current range affected, right? So our current range that we need to update is 1 comma 2, right? And now right now we are at node 0 comma 3. So see, first case, are they not overlapping? No, they are overlapping. So we'll be checking the second case, that this range, this 0 comma 3 range is completely lies inside this our uh, current range. So is that the case? No. Then what we do is we will be going taking the third case, that is partial overlapping. So what it does is this node will call its child, and before calling, what is push its lazy value. So already lazy value is 0. So it will add the value 0 to the both the childs, right? Then it will call 0 comma 1. So if you'll see 0 comma 1 and 1 comma 2, is there any overlapping? So yeah, 1 is a common between those two, right? So then again partial overlapping is there, so it will call its left child. So there is no overlapping, so it will return back. Then it's called its right child, 1 comma 1. So if you'll see, so 1 comma 1 exactly lies inside this range 1 comma 2, right? So what it does is it will update the minimum and maximum value of this, right? So our current value is minus 1 because the number is even. So what we update the minimum, maximum and the lazy value to minus 1, right? So if here, now we go back, so this node will update its value. So minimum is 0, minimum is minus 1, so minimum gets updated to minus 1. Maximum is 0, maximum is minus 1, so maximum gets updated to 0. So the minimum and maximum for this node gets updated. Then we go back, right? Now 0 comma 3 will call its child 2 comma 3. So 1 comma 2 and 2 comma 3 is partial overlapping, so it will call its child 2 comma 2, right? Now 2 comma 2 is fully present inside this 2 comma 2. So again minimum is minus 1, maximum is minus 1, lazy is minus 1. Now this, then it will call 3 comma 3, no overlapping, nothing will happen. So it will update also its minimum, maximum and lazy. Minimum is minus 1, maximum is 0 and minus 1 0. And from here 0 comma 3 will also update its minimum and maximum, right? So it will take minimum from both child, minus 1, so it will be minus 1, and maximum is 0 comma 0, that is 0. Okay, so we have updated all the ranges. Now what next? Now we'll be finding from 0 comma 2 we'll be finding an index L where a of L is equal to 0, right? That's what we want to find now. So initially, now what is our range? We want to find 0 comma 2. So 0 comma 2 will come, we will be checking in 0 comma 3, right? So is there a case of not overlapping? No overlapping is there. And then we check the minimum and maximum, that is it possible to get 0 in between this? Yes, minus 1 and 0, so we can get 0. So third case, if L is equal to R, no, L is not equal to R, then it will call its left child 0 comma 1. Again we will be checking those two cases. So 0 comma 1 and 0 comma 2 has some overlapping, and here also minus 1 and 0. And then third case, L is equal to R, no, L is not equal to R, so it will call its child. Now this child 0 comma 0, overlapping is there, and minimum and maximum we can get a 0. And third case, L is equal to R, so it will return L, so it will give us the index 0. So now the left child has given some answer, so we'll be returning 0. So 0 comma 3 will give us answer 0. So for this third case we get answer as 0. So our answer is R minus L plus 1, that is 2 minus 0 plus 1. So what the length we are getting? We are getting the length as 3, that is 2 3 2. So this is a balanced. So similarly we will be doing for all the elements, and at the end we will be returning the maximum answer. I hope I am able to show you properly, and you are getting it properly. Thank you.